Right, I said last time I'm going to have to look at more complicated scenarios. If I toss a coin twice, what's the probability I'm going to get a head or a tail? Now, this is more complicated because what I'm actually got is I'm going to say, okay, that could apply to a probability of a head, then tail, or a tail, then a head. Okay, that's what's really happening. It's two separate scenarios, a head and then a tail, or a tail and then a head, and that will both fulfill this condition here. So actually I should really stick an and in there. You can see that can then be said, okay, that can then be reduced to a head, probability of a head times probability of a tail, and, okay, or goes to and, the and goes to the multiplication sign, as I've explained before, probability of t multiplied by the probability of a head. So that's it. Half times a half added to half times a half. And you do the calculations inside brackets first, so that will be a quarter plus a quarter, which equals 2 over 4, which will reduce down to a half. And so that's quite logical when you think about it. You know, all probabilities of a particular scenario must add up to 1. So as I said in the last video, the probability of getting 2 heads will be a quarter, and the probability of getting 2 tails will be exactly the same numbers, and so that'll be a quarter as well. So you've got a quarter plus a half, and that covers all the scenarios, and the probability of all the scenarios adds up to 1, which is what you need. Now, this pen is running out a bit. Now, a simpler way of attacking this might be to use a tree. So what I would do is I'd start to attack the same problem. Right. I'm using this because my black pen is running out. Can you see that on here? Yeah. Oh no, I might try it again. Now, that's heads and that's tails, and the probability of each is a half. Okay, so that's my first step. Like, you know, remember I'm doing the same thing. I'm tossing this coin twice. So that's how I present the first step. Heads or tails, and I'd stick the probabilities on the branches, and those must add up to 1. Now do the same thing again. So I'm going to have a heads or tails, and likewise the probability there's a half. Okay, so that's the full scenario. Now what I do is I multiply across each branch, so that gives me a quarter. I mean, that corresponds to probability of a head and head, so that's a quarter as we've already calculated. I said it was symmetric, so that'll be a quarter as well, the probability of getting 2 tails. Now the probability of getting a head first and then a tail is a quarter, and the probability of getting a tail first and then a head is a quarter as well. So that's not too surprising that you've got 4 possible scenarios and the probability of each is a quarter. I need to do a full bit of a check here to check that all these scenarios do add up to 1 as well. Okay, that's quite important for obviously real life trees can get a bit more complicated than this, so you need to add up that these all actually do add up to 1. So the next scenario would be to just attack the problem. The problem said, what's the probability of getting a head or a tail? So you search out all the branches that you need. That's a branch there, corresponding to a quarter. That's another branch there, that's corresponding to a quarter. You add those up and you get a half. So the scenario is, you look for all the branches that satisfy what you're after. You're after all the branches that satisfy a head and a tail. You search them all out, and then you add the probabilities, and that'll give you a half as before. I'll just give a slightly more complicated example just to press the message home. If I've got to say a bag, sorry, 6. Okay, I've got a particular bag, 6 red balls and 4 blue balls. And I'm going to put my hand inside the bag without looking and pick out a bag at random. So if I start, the ball I'm going to pick out is either going to be red or blue. And the probability, hopefully you can see this, the probability of picking a red is going to be 6/10. And the probability of picking out a blue is going to be 4/10. So I won't bother to stick these down to the lowest terms. I'll just keep them as 6/10 and 4/10 because it'll make things easier at the end of the day. I'm then going to pick up, in the same manner, I'm going to pick up another ball. I should also have stated that the ball I've taken out in the first attempt, I haven't put it back in. Okay, I've taken a ball out and I've just discarded it. I'm going to do the same thing now again and pick out a red or a blue ball. Now, if I pick out a red, there's now only 5 reds left. So the probability of a red now is going to be 5/9. Okay, there's 9 balls left, and there's only 5 red balls. Probability of a blue is going to be 4/9. There's 4 blue balls, but there's 9 balls in the bag. If I get a blue, then there's only 3 blue balls. So the probability of red is going to be 6/9. And if I get a blue, there's only going to be 3 blue balls. So the 3/9, they're going to get a blue on the second attempt. So remember now that I multiply right across the each branch. So I mean that. Multiply across here, that's equivalent to saying the probability of a red on both occasions. So that's going to be 30/90. Okay. Again, I'm going to keep them in these figures. It's just be more convenient. So 6 times 5 is 30. On the bottom, 10 times 9 is 90. Same thing, same logic again for this. A red first and then a blue. That gives me 24/90. Okay, I'm multiplying right across the top and multiplying right across the bottom of these fractions. Here, blue first and then a red, that'll give me 24/90. And 2 blues, that'll give me 12/90. So check that these add up to 1. So what I need to do here, although I won't do it explicitly, I just need to add up the numerators, the number on the top. Okay, because all the numbers on the bottom, i.e. the denominators, are identical, so I can just add them up by adding across the top and putting them over 90. So it's 30 plus 24 plus 24 plus 12 is 90. So that's 90/90, and 90/90 is 1. Okay, do you need a reminder of that? 90/90 is 1, because 90 divided by 90 is 1, and so on and so on. So that's how you would set up a tree, and hopefully that would help you solve whatever problem it is. I mean, if the problem said, you pick 2 balls out in this manner, what's the probability of getting a red and a blue? Well, you first have to seek the relevant branches. That's that branch there and that branch there. Okay, you don't want this one. That's all reds and that's all blues. But the probability of getting 1 red and 1 blue is satisfied by these 2 central branches. So you select those branches, and then you look at the probabilities and you add them up. So you add those 2 up. Hopefully you can add them up in your head. Okay, you get 48/90. So under this scenario, you've got 6 reds and 4 blues. You stick your hand in this bag, draw a ball out without actually looking at the balls in the bag. You throw that ball away, and then you have another go with only 9 balls in the bag. What is the probability at the end of the day you're going to end up with the 2 balls you've taken out? What's the probability that at the end of the day those 2 balls are going to be 1 red and 1 blue? Well, that's the probability, 48 over 90. Right, cheers for now.